Our customers are constantly seeking ways to optimize their EC2 spends, which is often the largest portion of their monthly AWS expense. You may be wondering how AWS Graviton powered EC2 instances can offer you the best price performance compared to other similar size instances, potentially leading to significant cost savings. In this video, I will shed light on this very topic, specifically for .NET workloads, providing you with valuable insights and strategies to maximize your AWS total cost of ownership, that is TCO savings. Greetings, I am Santosh Kumar, a specialist solution architect at AWS, specialized in EC2 Graviton. My role revolves around assisting our customers, that is you, in adopting Graviton instances for their workloads. In this video, I will provide a concise yet comprehensive overview of AWS Graviton, dive into compatibility of different .NET versions with Graviton powered instances, walk you through the process of migrating a .NET workload to these high performing instances, and even showcase a demo of entire migration process. So without any further ado, let's dive in. Let's start with a brief overview of AWS Graviton. AWS Graviton is a family of custom-designed general-purpose processors developed by AWS specifically for cloud workload. It is a 64-bit ARM processor which has got targeted optimization to enhance performance of cloud workloads like web servers, media processing, high-performance computing, machine learning workloads, and more. AWS has launched 3 generations of Graviton processors till now. The first generation was launched in 2018, second was in 2019, and third generation Graviton processor was launched in 2022. Graviton powered instances can lower total cost of ownership, that is TCO, significantly for our customers. It provides up to 20% lower cost and on an average 20% better performance when compared to other instances with same vCPU and memory configuration. This leads on an average 40% better price performance versus comparable x86 based instances. For .NET workload specifically, it provides on an average 50% better price performance versus comparable x86 instances, 20% due to lower cost, and 30% due to better performance with latest version of .NET. Graviton processors are up to 60% more energy efficient as well versus comparable x86 instances, which helps our customer achieve their organization's sustainability goal. AWS Graviton processor supports a broad range of workload, including but not limited to web and gaming servers, high performance computing, media encoding, analytics, open source databases, in-memory cache, electronic design automation, microservices, and more. Before we proceed, let's clarify a few terms I will be using interchangeably throughout this video. When I mention Graviton, I am referring to ARM-based CPU architecture, often denoted as ARM or ARM64. Similarly, I will use Intel, AMD, or x86 interchangeably for x86-64 CPU architecture. With that said, let's shift gears and talk about different versions of .NET and its integration with Graviton powered instances. .NET is a software development framework developed by Microsoft. It is designed to be language independent. It supports multiple programming languages such as C#, Visual Basic, F#, and more. Microsoft originally released .NET as .NET Framework in 2002, which was Windows-centric and had no support for ARM64. Since Windows Server do not support ARM64 architecture, .NET Framework application cannot run on Graviton instances at this time. ARM64 support in .NET was added with .NET Core in 2016, which was also the cross-platform version of .NET. .NET Core 3.1 was the first .NET version with SDK support on ARM64. All newer versions of .NET post .NET Core 3.1 are supported on Graviton instances, including .NET Core 3.1. In 2020, Microsoft released Unified .NET, which merged all different .NET platforms, including .NET Framework and .NET Core. All unified .NET versions, that is .NET 5, .NET 6, and .NET 7, are well supported on Graviton processors. In summary, .NET Core 3.1 Plus and .NET 5 Plus are supported on Graviton instances, whereas .NET Framework isn't supported on Graviton instances. However, there are strategies using which you can port .NET Framework application to Graviton instances, which I will talk about in later part of this video. I would like to draw your attention to support status of different .NET versions from Microsoft. All versions of .NET Core and .NET 5 have already reached their end of life. Therefore, we highly recommend utilizing the newer version of .NET such as .NET 6 or .NET 7 when running your workloads to Graviton instances. Not only do these versions provide improved performance, but they also benefit from optimization specifically tailored for ARM64 architecture. Now, let's talk about benefit of running .NET workloads on Graviton powered instances. First one is cost saving. Here, I am showing a comparison between Intel powered Windows instances and Graviton powered Linux instances in Oregon region. However, the saving shown here is more or less same in other regions as well. As compared to Windows instances, Graviton 2 powered instances are 59% less expensive and Graviton 3 powered instances are 57% less expensive. So, you save significantly when you move your workload from Windows to Graviton powered instances. Please note that these savings you get are due to elimination of licensing fee as well as due to less expensive Graviton instances. The performance benefit of running your workload on Graviton instances are additional, which I want to talk about as next benefit of running .NET workload on Graviton instances. With .NET workload, Graviton instances on an average provides up to 30% better performance with latest version of .NET. To test these performance numbers, one of my colleague, Kirk Davis, who is a principal solutions architect in Microsoft platform team, has done some benchmarking and published the results in his blog, which I've linked here. He used two applications for his benchmarking, ASP.NET Core MVC and Web API apps targeted for .NET 5. The first three applications in this chart are ASP.NET Core MVC app returning 2 kilobytes, 60 kilobytes, and 2 megabytes of serialized JSON. The last three applications are Web API returning weather forecast results, 100 weather forecast results, 500 weather forecast results, and 100 weather forecast results again, but encrypted this time. As you can see, for all different workloads, Graviton instances outperformed Intel instance in terms of price performance benefits. The MVC app returning 2 megabytes of JSON on Graviton instance provided 64% better price performance as compared to Intel instances. When same tests were run on Graviton 3 instances with .NET 7, he found that the MVC app returning 2 megabytes of JSON was providing 82% better performance as compared to Intel instances, which is a 20% jump from Graviton 2 instance price performance. However, the Web API app returning encrypted weather forecast data provided best price performance on Graviton 3 instances, which was 130% better than Intel instances. This shows that for compute intensive workload, Graviton 3 instances provides much better price performance as compared to Graviton 2 instances, which were already providing better performance as compared to x86 instances. Price performance benefit of .NET workload on Graviton instances are not restricted to EC2 instances only. Our serverless compute services, Lambda and Fargate also supports .NET on Graviton. You can even deploy your codes to ARM64 Lambda function right from your IDE using AWS Toolkit for Visual Studio. The last but certainly not the least benefit of running .NET workload on Graviton I want to talk about is energy efficiency. Graviton processors are up to 60% more energy efficient over comparable x86 instances. This not only translates to cost saving for your organization, but also results in a reduced carbon footprint for the same workload and traffic pattern. This will help you achieve sustainability goal of your organization. This environmental impact gives me personal satisfaction as it resonates with the broader mission to address pressing issue of climate change. Now let's talk about the migration process of .NET workload to Graviton powered instances. Migration of supported version of .NET workload to Graviton is largely the same as migrating any other interpreted or bytecode compiled language applications like Java, PHP, Node.js, etc. The overall migration process can be divided into two stages. In stage 1, you create software dependency inventory of your application and list all dependencies including language standard, open source and commercial dependencies, or libraries along with any security, monitoring or logging agents used by your application along with its versions. Once you have the inventory, identify ARM64 support for each of the dependent libraries and agents. While identifying dependencies, there are two common gotchas that you should be aware of. One is native dependencies, which are external libraries or DLLs may be written in C# or other lower level languages like C or C++. Porting these generally requires recompilation of the library if there is not any available already. Second is platform specific code like libraries written in assembly. Porting these are more involved and requires rewrite of the library if there is not any available already. But the good thing is these are not very common. However, if you need any help in identifying the ARM64 support for your application or its dependency, please reach out to your AWS account team or to our Graviton team using this email address, which is ec2-arm-dev-feedback@amazon.com. In stage 2, you perform POC by launching Graviton instances, deploy your software stack on it, and then test it. We recommend to perform all tests that you generally perform for your application. If needed, write new test cases as well to ensure your application works on ARM64 architecture the same way as you expected it to. Once all test passes, then deploy the application into your pre-prod or prod environment using your preferred deployment techniques such as blue-green deployment, canary deployment, A/B testing, etc. These step-by-step migration process are also documented in our Graviton technical guide hosted on GitHub. I highly recommend you to bookmark this link as it will be a good reference for you during your Graviton migration journey. Okay, so that's about how you migrate supported .NET version to Graviton. But what about non-supported .NET version, that is .NET Framework application migration to Graviton instances? As .NET Framework application cannot run directly on Graviton instances, prior to migration, we recommend to refactor the .NET application and port it to latest version of .NET like .NET 6 or .NET 7 and then migrate to Graviton instances following the steps which I described previously. There are multiple benefits of porting .NET Framework workload to latest version of .NET. It helps you modernize software stack of your application and reduce tech debt. Applications using latest version of .NET, that is .NET 6 or .NET 7, can easily be ported to Linux and Graviton instances, so you get freedom from Windows licensing. You get better performance as well when you migrate that to Graviton instances, which in combination with instance right sizing will help you reduce cost of your application even further. You can containerize your application and use mature container orchestrators like Elastic Container Service ECS or Elastic Kubernetes Service EKS and more to deploy and manage your application at scale. It also unlocks the world of serverless for you, where you can deploy your applications to AWS Lambda and forget about server management. However, porting applications from .NET Framework to .NET has few challenges as well. For example, .NET Framework has strong ties with Windows ecosystem and it has a lot of APIs which are not compatible with .NET. Many of the NuGet packages of your application may not be compatible with .NET. Finding all these incompatible APIs and NuGet packages manually is a laborious and time-consuming work. And once you have identified those incompatibilities, then porting that manually makes it even harder. To help you with the porting process, AWS has a tool called Porting Assistant for .NET. It is an open source tool which can help you identify incompatible APIs and NuGet packages in your application by scanning its source code. It can also port 60 to 70% of your code to .NET automatically and help you find the remaining incompatibilities and relevant resources so that you can port remaining code easily. There are some prerequisites which you should be aware of before using Porting Assistant for .NET tool. It doesn't support all .NET Framework versions. It can help you port applications with .NET Framework version 3.5 or higher. So, if your application uses older version of .NET Framework, then you need to upgrade to .NET 3.5 or higher before porting it with this tool. You should have access to your source code and solution file in order to use this tool. You will require to have both sides of runtime installed in your system where you are porting it. Not all .NET Framework applications are supported by this tool. ASP.NET MVC and Windows Services are two popular .NET Framework applications this tool supports and does a lot of heavy lifting during the porting process. It also has limited support for ASP.NET Web Forms, WCF apps, and VB.NET Web APIs, class libraries, or console applications. For any other applications written in any other languages like VB.NET, you first need to port that to C#. There are tools available to help you with that, and then port the application to .NET with this tool. This is another version of the tool which is an extension for the Microsoft Visual Studio, and it is called AWS Toolkit for .NET Refactoring. The functionality is exactly the same as Porting Assistant for .NET. However, it helps developer to port .NET Framework applications to .NET directly from their IDE. Now that we have explored the advantages and sustainability benefit of Graviton instances, it's time to show you how easily you can migrate a .NET workload to Graviton powered instances. In this demo, I will show you how I ported a .NET Framework 4.7 application to .NET 6 using Porting Assistant for .NET, how I containerized it on Linux, how I created a multi-architecture container image out of it, and how I deployed it to a EKS cluster on Graviton nodes. This is the sample application I have, which I will be using in my demo. It is available in AWS samples GitHub repository and it's public. It is basically a simple online shopping app built using ASP.NET MVC 5 with target.NET version as .NET Framework 4.7, which is the Windows-centric version of .NET. I have already cloned this repo in one of my Windows instance and opened it in Visual Studio. The .NET version of the solution can be confirmed by inspecting its properties. As you can see, the target .NET version for this particular application is .NET Framework 4.7.2. Let's close this. To run this application on Graviton instances, it first needs to be ported to .NET 6 on Windows and then to Linux on Graviton instances. Why .NET 6? Because it's the latest .NET LTS long-term support release. Before I start the porting process, let me run this application and show you how it looks. This is how the application looks. It is a simple shopping app with sample product categories and a shopping cart. Let's close this. To port this application to .NET 6, I have used our porting assistant for .NET tool. This is how the tool looks. To set target .NET version to which the application will be ported, click on Settings and then set the target framework over here, which I have already set it to .NET 6 in this case. Let's go back. To start porting, click on Get Started and then click on Assess a new solution. Then browse and select the location of your solution file and click on Assess. After this, the tool will start scanning the source code of the solution, and at the end of it, it will present you with its findings. Since in this case I have already done the assessment, I will click on Cancel instead. Once the assessment is done, this is how the tool will present you with its assessment findings, which includes number of projects scanned, detected incompatible packages and incompatible APIs with target.NET version, any build error, and action that needs to be taken in order to port this application to target.NET version. If you click on the solution name, it provides more details of the assessment with different views like project view, which provides analysis details of each project identified in the solution. A NuGet package view, which provides compatibility detail of each NuGet package detected in the solution. API view, which provides details about .NET API incompatibilities the tool has identified. And the source file view, which provides details about which source file has how many .NET APIs, and out of that, how many are incompatible with target.NET version. To drill down further, click on the source file name and it takes you to an annotated version of the source file, which points to incompatible APIs and explains what action the tool will take if you port the application using this tool. Where there is no porting action annotation available, it indicates that the tool won't take any action while porting this application to target.NET version, and developer would have to port that manually. To port this application, click on Port Solution. During the porting process, it also generates logs which you can analyze to understand the specific challenges regarding any incompatible APIs, NuGet packages, build errors, etc. As you make changes in the code, you can reassess the solution to track how much changes has been done and how much more needs to be done for tracking purposes. I have done the porting already with necessary code changes, and here is my ported application. It's exactly the same application, so if I run this, you will see the same web page. Let's close this. However, if I check the properties of the solution, you will see that the target.NET version is .NET 6 in this case. Let's close this. Now that I have my application ported to .NET 6, I can containerize it and run it on Graviton instances. For that, I will use Visual Studio feature to generate Docker file for my solution. Please be aware that the Docker file generated via Visual Studio has no intelligence to identify ARM64 incompatibilities and fix that. It is just a convenient way of generating a Docker file for your solution. So, if your Docker file contains any x86 or Windows specific instructions or binaries, then those has to be fixed before building the container image on Graviton instances. Since in this case I have already generated the Docker file, so I will click on cancel instead. Porting this application to Linux on Graviton instances was straightforward because it doesn't have any Windows or x86 specific dependencies. If your application have any of those, then those has to be ported separately. Once you have the Docker file and you have taken care of the Windows and x86 specific dependencies, then the next step is to build multi-architecture container image. For this, you will need to build two container images separately on x86 and Graviton instances and push it to ECR, and then combine both into a single multi-architecture image using docker manifest create command. To show you this, let's switch to my terminal. Here, I have already logged into a x86 EC2 instance in left pane of my terminal and to a Graviton instance in right pane of my terminal. I have also copied the ported application code to these instances already. To create container image, I need to run same commands on both the instances. So to save some time, I will use pane synchronization feature of tmux to execute commands on both the panes simultaneously. Now let's execute this command to get AWS account ID of my account. Let's log into the ECR so that we can push our container images to our ECR repository. Let's create a variable for ECR repo. Now let's navigate to the directory where I have copied my ported application. Now let's create the container image using docker build command. It will take few seconds to create the image. Now let's tag these images with our ECR repo name. And then let's push these images to ECR. Looks like I executed wrong command on the x86 instance. Let me stop the pen synchronization and execute the push command again over here. Let me clear the screen. Now let's list the images that has been pushed into the ECR repo. Let me make this full screen so that you can see the commands easily. So as you can see, now we have two images in our repo, one for x86 architecture, another one is for ARM64 architecture. Now let's create a multi-architecture image by combining these two using docker manifest create command. And let's push this to our ECR repo as well. And then let's list the images that we have in our ECR repo again. Now, as you can see, apart from the architecture specific images, we also have a multi-architecture image in our repo with tag v1. Once the multi-architecture image is created, you can use usable deployment techniques to deploy it in your pre-prod or prod environments. In my case, I already have the x86 version of this image deployed in my EKS cluster, which I created for this demo. For this, let me exit from here. Let me clear the screen. Let's list the pod to see what are the pods running. And as you can see, there is a Gadgets Online application pod already deployed. And this deployment is being fronted by a load balancer service. So let's list the load balancers. And this is the DNS hostname of the load balancer. Let's hit it in our browser. And as you can see, our application is running over here. If you notice, the instance type from which this particular web page is being served is m5.xlarge, which is x86 based Intel instance. This is the YAML file which I used to deploy this particular application. As you can see, the deployment of this application is using x86 specific container image. Now I will modify it to use our multi-architecture container image which we created few seconds back. So the tag of our multi-architecture image was v1 and the repo name was demo app repo. So I will remove this x86. If you notice, I have also used node affinity to ensure all the ports created by this deployment lands on x86 node. I will modify it to ARM now. To ensure now all the port lands on Graviton instances. Although our image over here is multi-architecture image and can run on Graviton as well as x86 instances without any issues. But for the purpose of this demo, let's run it on Graviton instances only. Now let's apply the changes. And let us list the pod again. As you can see, we have a new pod created and it's running from last 23 seconds. Now let's go to the browser and refresh this page. Since there is no difference in the application over here, you will not notice any difference over here. Now, if you notice the instance type over here, this particular web page is being served from a Graviton instance, which is m6g.xlarge instead of m5.xlarge as it was earlier. So we have successfully migrated our .NET Framework application to Graviton instances. That is all I wanted to show you as part of this demo. Now let's go back to our slide deck. For any questions related to Graviton processes, please refer our Graviton technical guide in GitHub. It will help you answer most of your queries you may have regarding Graviton processes, workload or software supported on it, performance tuning of a workload on Graviton instances, and more. There is a dedicated page for .NET as well, which lists supported version of .NET on Graviton and performance improvement made in .NET Runtime, which helps .NET application perform better on Graviton instances. If you could not find any specific Graviton related information you are looking for in there, please feel free to open a issue and we will do our best to help you answer your queries. Here are some of the useful links, which includes AWS Graviton processor page, which will help you identify EC2 instances powered by AWS Graviton processors. This blog walks you through the process of building and deploying a .NET workload on Elastic Container Service, which is ECS. This is the sample application which I used in my demo. And these blogs contain commands I used to create multi-architecture container image in my demo. Before we wrap up, let's summarize what we learned in this video. We learned that AWS Graviton powered instances provides best price performance versus comparable x86 based instances. Application written in .NET Core 3.1 Plus and .NET 5 Plus can be easily migrated to Graviton instances. However, please watch out for native and platform specific dependencies. Those needs to be ported separately. .NET Framework application cannot run on Graviton instances directly and needs to be refactored to newer version of .NET like .NET 6 or .NET 7 before migrating to Graviton instances. We also learned how to containerize and create multi-architecture container image of a .NET application. Thanks a lot for your time, and I wish you a happy Graviton adoption. Have a nice day.